Welcome to 9-5. We are still looking at systems of equations, and this time we're going to be looking at something called special systems. And you'll see what that means here in just a few minutes. First, our math career, a mechanical engineer. Mechanical engineer, these people research, design, develop, manufacture, and test tools, engines, machines, and other mechanical devices. Engineers in this discipline work on power-producing machines, such as generators, combustion engines, steam and gas turbines. They also work on power-using machines, such as refrigeration, air conditioning equipment, machine tools, elevators, escalators, industrial production equipment, and robots even. So quite a broad spectrum of things that a mechanical engineer can do. You can see they're well compensated for their education and for the time they spent getting ready and for the skills they bring. Great job. Especially get to work with your hands and your mind and a computer and math. What can be better? All right, today we will learn how to solve a system of equations with special solutions. And what is that going to mean? So now here's some vocabulary for us. To coincide. In regards to mathematics, two lines that coincide actually overlap each other. Coincide. So if two things coincide, we tend to think of time. Two things coincide, they overlap in time. In this case, in math, it's actually going to be a line or some kind of shading that overlaps. Okay. All right, so we have been solving systems of equations in several different ways, each time finding values that would solve both of the equations at the same time. Remember, that's the whole point of a system, finding the solution that would solve both equations simultaneously. So, for example, this one here, if we actually graphed these two lines, this one in blue, this one in red, what's the solution here? Well, the solution here is, well, starting at the origin, over 1, up 1, the solution's 1, 1. Now, there are two other possibilities. What can you think? We have two lines that overlap, or that crisscross like this. What are the other two possibilities drawing in a two-dimensional plane? So, let's see. What if we had something like this? Y equals 2x minus 3 and y equals 2x plus 2. Now notice what happens here. Here's the red line. Notice it crosses the y-axis at positive 2 with a positive slope. Look at this one, the blue one. These lines have the same slope. Right here, what was our m in this case was 2 and 2, but they have two different y-intercepts, so therefore these lines are parallel. If two lines are parallel, they're not going to cross, right? So we would have no solution. If you actually solve this system without using a graph, you would eventually find, using algebra, there's no solution here. And we'll see how we do that. What about this one? The blue one says y equals 2x plus 2. The red one says the same thing. So if I drew the blue one, and then we said, okay, let's forget about that and draw the red one, well, we get the same image. The last possibility is that equations are the same and they graph exactly the same line. And we call this two lines that coincide. Coincide. So what's in red here is going to be important, so please add this to your notebook. When graphing, it's easy to see if the lines intersect, that's one solution. If they're parallel, no solutions. Or if they're coincide. Coincide means they have infinitely many solutions. You can pick any ordered pair you want, and on that line, it'll cover both equations, obviously, because the equations are identical. Now, how do we determine the outcome of our systems without graphing? What if we don't have the means or the desire or even the requirement is not to graph? How do we determine the outcome? So here's what we'll do. Let's take a look. Just watch, please. We've already seen this. Look, if you look here, if we want to solve this, easiest way to solve by addition, notice that the y's have opposite coefficients. So we add straight down, and we end up with 4x equaling 8. So x obviously is 2. Plug that into the bottom equation. Go ahead and solve for y, and it looks to me like y is going to be negative 1. So there's our solution, 2, negative 1. So if you graph these two lines, where would they intersect? Well, these two lines graphed would intersect at 2, negative 1. So if you had a coordinate plane, it would be over 2, down 1, and sure enough, those two lines would cross right there. Now, what about this one? Y minus x equals negative 4, and negative x plus y equals 3. A little bit tricky here because Notice that they didn't line these up nicely for us. So let's see what we can do. First of all, rearrange the terms so they align. Okay? So all I'm going to do is just switch them around so the y's are over the y's and the x's are over the x's. It's okay that x doesn't come first here, as long as in your answer, your x comes first. All right, let's see. So multiply by -1. Okay, we can do that. That will give us a switched out signs, reverse the signs so we can add straight down. And now let's do so. So algebraically here, we're going to start adding. And what is y plus negative y? And what is negative x plus positive x? Well, that's just two zeros added together. But what is -4 plus -3? Well, that's -7. And now what we're saying is 0 plus 0 is -7. Well, we know, of course, that's not true. So this is called a contradiction. And in algebra or in logic, when you have a contradiction, this simply says that we have no solution here. No solution. Okay? So no solution because these are parallel lines. If you were to actually identify the slope of these lines, you would see that the slopes are identical. So in this case, if we were to isolate y, we'd add x to both sides. I'd get y equals x minus 4. I don't care about this as long as it's different or it'd be coinciding, right? This y-intercept. Let's look at this guy. If we were to move the x over, negative y equals negative x minus 3, but now I multiply through by -1 to make this a positive y, and I get y equals x plus 3. Notice our slope here is 1, our slope here is 1, so these lines are parallel. Two parallel lines are never going to cross, so we have no solution. Okay, good. So, well, look at that. It's already set up for us. Notice they both have a slope of 1, and so they're parallel, and there's no solution. Okay, let's see. Let's take a look at this one. So let's watch this. We got 2x minus 4y equals 10, and x minus 2y equals 5. And let's multiply the bottom by -2. Sounds good to me. That's going to give us a -2x here. So multiply through. Now if we add straight down, what happens here? Well, now we're looking at 0 plus these two cancel, and sure enough, 10 plus -10 is going to be what? 0. Well, now we get something called an identity. And an identity says one side equals the other. Of course, it's true. 0 equals 0. So we have something that identically matches something else. So in this case, these two lines have infinitely many solutions. These two lines actually would coincide. If you look carefully here, what if we multiplied everything here by -1? Wouldn't these match, and these match, and these match? So we're looking at two identical lines here. Infinitely many solutions. Hey, that's it for 9.5. All right, looks like we just got something big, and then it just stopped. So that's okay. We will be together soon. Of course, you can practice on your own right there. It's a digital scored practice. And we'll have plenty of time to work this out and see these different types of solutions. Remember, there's 3 types in a two-dimensional plane. 1 point, they cross at one spot. Parallel lines have no solution, and lines that coincide have infinitely many solutions. Enjoy.